Okay, section 6.9 is converting between measurement systems. So maybe you have kilometers per hour and you want to express it in meters per second. So we might have to change both units within that rate. Let's take a look at try these. It says express each amount in the unit given to the nearest hundredth. So these are within linear measurements, the first two. So miles is imperial, kilometers is in metric. They've given us the conversions here, although you can look in the back of your book as well. So if 1 mile is 1.61 kilometers, then 3 miles means we have to multiply this by 3. So you can get out your calculator. 1.61 times 3 is 4.83. Okay, then centimeters to inches. Again, you can look in the back of the book, but it has a conversion here. 1 centimeter is 0.39 inches, so we're going to multiply this by 4. Oops, that's the wrong one. So 0.39 times 4 is 1.56. Sorry. Inches. And then gallons to liters. So 1 gallon is 3.79 liters. So we're going to multiply that by 2 because we want it for 2 gallons. So 3.79 times 2 is 7.58. Okay, first example says Bianca reads that the speed of sound is about 1,116 feet per second. How fast does the sound of thunder travel in kilometers per hour? So the sound, how fast does it travel? We need to convert from feet to seconds to kilometers per hour. So first we'll convert from feet to kilometers, keep the same per second. Okay, so just remember here, you might want to think about this as feet. If I show it like this, then you know that your seconds are remaining in the denominator and you want to divide out feet. So we're going to multiply by however many meters are in a foot, because then the feet units divide out. Then we're going to multiply by however many kilometers, multiply through by kilometers over meters, because then these meters divide out. So we know this, 1,000 meters is 1 kilometer, but you might not have memorized how many meters in a foot, although over here they're giving you a hint, so you don't have to look it up. So 0.30. So then all you're doing is multiplying these three, and then this is seconds, remember, so I'll do it like that. It's not a 5. So multiplying those and then dividing by 1,000. So 1116 times 0.3 divide by 1,000. So 0.3348. Okay. That's kilometers per second. And that makes sense, right? 1 foot is much smaller than a kilometer. So this is going to be a small number. Then speed of sound in kilometers per hour. So now we have this. I'm not going to round it. I'm going to keep that. That's kilometers per second. So again, I'm going to show that over seconds. And then I'm going to multiply by the equivalent of 1 within that conversion factor, right? So in 1 minute, there's 60 seconds. So by multiplying through by that, we're not changing the rate at all, because 60 seconds is the same as 1 minute. So it's like multiplying this by 1. Okay, but we're getting it now. So the seconds divide out. So now we're into kilometers per minute if we stop there. But we want to get it into kilometers per hour. So then we're going to multiply. Well, in 1 hour, there's 60 minutes. So then the minutes here divide out. And so now you're left with kilometers per hour. There and there. So we need to take our calculator, it's already in there, and multiply by 60 and then by 60 again. So 1205.28. Oh, sorry. 205.28. So it travels about 1,205 kilometers per hour. Okay. All right. Ramo and Braden live 20 kilometers apart. Each collected rainfall data during the same storm. Who had the greater rate of rainfall? So rate of rainfall. So that means in a time period. So the change in the rainfall divided by the change in the time. So let's take a look. The workbook takes us through it. What is the rate of change in the amount of rainfall collected by Ramo between 1 and 3 hours? So the rate between these might be a little bit different than these, but overall we're doing the whole thing, although it doesn't look like it's any different. So we are going to take, this is our second point, the 3 hour 2.1 inches, and 1 hour 0.7 inches as our first point. So 2.1 minus 0.7, so that's the change in the inches is 1.4, and then 3 hours minus 1 hour is 2 hours. So then take 1.4 divided by 2 and you get 0.7 inches per hour. Okay, so that's the rate on average that it was raining where Ramo lives. Notice how Braden is in millimeters. So different unit, so that's why we can't compare the numbers right away. So 57 and 19. Okay, so 57 minus 19 is 38 over 2, which is 19 millimeters per hour. What is the rate in millimeters per hour for Ramos? So now we have to convert to the same unit. So the workbook's deciding to take Ramos, go from inches to millimeters per hour. We could do the opposite and take Braden's and go to inches. But Ramos was 0.7 inches per hour. So then we want to multiply by how many millimeters in an inch. Okay, so again, you can look in the back, but it's given to you here, 25.4. So we're not changing the rate at all. It's just changing to a different unit, right? So now the inches divide out, and so we'll get millimeters per hour. And so we need to multiply 0.7 by 25.4. 17.78. Okay, so who had the greater rate of rainfall? That would be Braden, because his was 19 millimeters per hour, and Ramos's was 17.78 millimeters per hour. Okay, Bensi is draining a water heater so he can repair it. The graph on the right shows the rate. How fast is the water draining in milliliters per second? So yeah, it's showing at time 0, the water was, take a look here, each 2 is 10, so that would be 50. And after 30 minutes, it was empty. So the rate of change, so basically my point here is 0.50, my point here is 30.0. So we'll use this as our second point, this is our first. So 0 for y minus 50 for y, 1, and then 30 minutes minus 0. So that'll be negative 50 over 30, which is negative 5 over 3, which is, you can do it in your calculator, but negative 1.6 repeating. And so if we do, say, go to 1 decimal place, it's going to be negative 1.7. We round it. And the negative means it's decreasing. Okay, so the water's going down. It's draining. What is this rate of change in milliliters per second? So this is gallons per minute. And I'm going to keep it exact, okay, 1.6 repeating. So in my calculator, I'm going to do that negative 5 divided by 3. So I have it exact there. Then I want to convert it to liters. So gallons, I've got to multiply by liters per gallon. So there are 3.79 liters in a gallon, it says on the right there. So we've got to multiply so that the gallons divide out, and that will give us liters per minute. So times 3.79. Negative 6.316 repeating. Negative 6.316 repeating. Okay, so then we take that. I don't round anything till the end. And then I want to convert from liters to milliliters. So I know that there's 1,000 milliliters in a liter. So again, the liters divide out those units. And then I've also got to convert to seconds. So now, if I just do those two, I've got it in milliliters per minute. But now I need to convert to seconds. So minutes is in the denominator. So my ratio has to have the minutes in the numerator. So 1 minute is 60 seconds. And multiply those. So when I do this in my calculator, I've already got the first number. I'm going to multiply by 1,000 and then multiply by 1 divided by 60, or you can just divide by 60 right away. Negative 105.27 repeating. Okay, so basically, approximately, it's draining. So if it's draining, I don't need to put the negative. That means negative. So it's draining at about 105 milliliters per second. So you can either use the word draining or the negative, or word decreasing instead of draining. But that's how you do some conversions. You might have to do them in multiple steps. Okay, so do the practice for that. And then 6.10 is optional. And so then I suggest we just going to the chapter review and chapter test to finish off the workbook work.